Scientific notation is a way that we are able to write very large or very small numbers in an easier way to comprehend what they are. Specifically, it's a number that's written in this format here. A times 10 to the b power, where a is a number between 1 and 10. A can be equal to 1, it cannot be equal to 10, and b is an integer. Essentially, a needs to be what we can think of as a single-digit number, but it could have decimals on it. And then b is an integer, meaning that 10 to the b power is just going to be some power of 10. So now we want to write the following numbers in scientific notation. So to start off, we have 50,000. And I like to explain this where we're going to take a look at the number 50,000. And where I want the decimal place to be is right after the first non-zero digit. So our first non-zero digit on here is the 5. So I want my decimal place to be right after the 5, to have 5.0. But now obviously 5.0 is not the same thing as 50,000. So we need to multiply this by 10, and we need to figure out what that exponent should be. So now we're going to go back to the 50,000 that we started with and think about where the decimal place originally is. When we just have the number like 50,000, the decimal place is always at the end there. So now what I'm going to do is count how many places I have to move that decimal place in order for it to be right after the 5. So we have 1, 2, 3, 4 places that we have to move it. So that means my exponent on the 10 is going to be 4. So I'm going to have 5 times 10 to the 4th power. And we can think this through. If you were to then evaluate what 10 to the 4th power is, well, that is 10,000. So 5 times 10,000, that is the same thing as 50,000. The next problem, we have 420 million, and we want to write this one in scientific notation as well. So this means that I'm going to take a look at my number here, and I have 2 at the beginning. So what I'm going to do is put the decimal place right after the 4. So that gives me 4.2, and then I'm going to have times 10, and now I need to figure out what that exponent on the 10 should be. This means I'm going to count the number of spaces I would have to move the original decimal place in order to make it so it's where I want it to be after the 4. So we have 1, 2, 3, 4, 5, 6, 7, 8. So that means I am going to have 10 to the 8th power. So in scientific notation, it's going to be 4.2 times 10 to the 8th. The next number that we have here is the 0.0000008. So with this, I'm going to take a look at, find my first non-zero number on here from left to right, and we have that it's an 8. So that means I want my decimal place to be right after that. Technically, I wouldn't need the 0.0 on this one or on the first problem that we did either, but I'm essentially just writing it for emphasis to show where that decimal place is. So I'm going to have 8 times 10, and now I need to figure out my exponent. So it means I'm going to count how many spaces I have to move my decimal place in order for it to be where I want it to be. So we have 1, 2, 3, 4, 5, 6, 7, 8. So I have an 8, but I don't want positive 8 because 10 to the positive 8 power is a very large number. That's 100 million. Obviously, I'm not starting with a very large number here, so I don't want to be multiplying by that. What I instead want is 10 to the negative 8 power, because 10 to the negative 8 is a very, very small decimal, which is going to give me back that small number that I had at the beginning. The next one, we have 0.00023. So to write this in scientific notation, we are going to get 2.3 times 10, and then I need to move the decimal place 4 spots, but I'm starting off with a very small number, so this needs to be a negative 4. Next one, we have 208,000. So to put this number in scientific notation, we're going to have 2, and then I'm going to do 0.08. And then multiply that by 10. And now we have to move the original decimal place 5 spots in order for it to be after the 2. So this is going to be raised to the 5th power to give us 2.08 times 10 to the 5th power. And then lastly, we have 0.02004. So my decimal place, I need it to be after the 2, so we're going to have 2.004. And then that's going to get multiplied by 10, and then 10 needs to have the power of being negative 2. Okay, so that was putting numbers into scientific notation. Now we're going to go the other direction and take numbers that are in standard or scientific notation and put them into standard notation, just like our regular numbers. So to start, we have 1.5 times 10 to the 3rd power. So this will then give us our 1.5, but now I need to multiply this by 10 to the 3rd power, so I am going to move the decimal place 3 spots to the right. So 1, 2, 3, and now we can fill this in with zeros. So this means we would have the number 1,500. The next one, we have 3.7 times 10 to the 5th power. So we're going to have our 3.7, but now if I want to multiply it by 10 to the 5th power, I need to move that decimal place in the direction that's going to make the number larger. So that's going to be to the right. So 1, 2, 3, 4, 5. And now we can fill that in with zeros. So that gives us 370,000 for what that number would be. The next one, we have 2 times 10 to the negative 7th power. So this means I technically have my 2, and then the original decimal place for this would be right after the 2. But now I need to move the decimal place 7 spots, but I need to move it in the direction that's going to make it smaller, because 10 to the negative 7th power is a very small number. So that means we are going to need to move it to the left. So 1, 2, 3, 4, 5, 6, and 7. So that is where my decimal place is going to be now. So we're at 0.0000002 as our number for this one. The next one, we have 7.38 times 10 to the negative 2 power. So if I write down my 7.38, that means when it's being multiplied by 10 to the negative 2, that means we need to move the decimal place 2 spots to the left. So 1, 2. So now we're at 0.0738. The next one, we have 4.56 times 10 to the 0 power. We have our exponent being 0, which means our decimal place isn't going to move at all. Our number is simply just 4.56. Another interesting fact, whenever we have 0 as an exponent, that number is simply just 1. So anything to the 0 power is just 1. And then lastly, we have 4.776 times 10 to the first power. 10 to the first power is just 10, so we're just taking this number and multiplying it by 10, meaning we're moving the decimal place over 1 spot to give us 47.76.